Hi, this is Professor Stugard, and we are going to briefly discuss how we can do linear modeling with added categorical variables. All right, so our goals for this lecture, first of all, what does a categorical variable mean? And then second, how can I create models based upon our categorical variables as well? So again, we have two types of variables. There's either categorical or quantitative. Or numerical. So our categorical variables are basically variables that just aren't represented by numbers. Or even if they are represented by numbers, there's no meaningful way to add and subtract those numbers as part of the variables. So what we want to do is, again, categorize our explanatory variables into groups. Now, those groups might contain numerical data themselves, but the groups are categorical in nature. So to explain what I mean, I think an example should help. So let's say I want to compare life expectancy across all the different continents for the year 2007 using my Gapminder data set. Now, the Gapminder data set counts 5 different continents. You have Africa, then the Americas, North and South America, are combined into one continent, then Asia, Europe, and Oceania. All right, so those are the 5 continents that Gapminder considers, which means there's 5 levels to that factor continent. Continent is a categorical variable. All right, so that is a variable about where you live, right? The continent that you live on is your variable. There's no numerical way to add and subtract. You know, say Europe minus Asia doesn't make any sense. It's a categorical variable. But again, if I'm comparing life expectancy, that is a quantitative measure. So there's a quantitative measure, all right, but my categorical variable is continent. So we're going to load the Tidy Models package, and then again, I want a data frame with only the results from 2007. So install the packages for Tidy Models, and then I'm going to create a data frame called year 2007 from my Gapminder data set, where I filtered out only the results from the year equal to 2007. All right. So again, year 2007 is my new data frame. Now I want to determine, well, those key numerical statistics. So again, we're starting with our Tidy Models functions. So it's a linear regression. That gets piped into the set engine. So again, I'm going to set engine in quotes for a LM, which stands for linear model. Then that gets piped into my fit function. And again, I'm going to fit life expectancy. And I want to group now my explanatory variables by the continent. All right. So I want to see, is there a difference based upon the continent that you live in? So this is a categorical variable, right? Continent is a category. My data set comes from my data set I just created, my data frame the year 2007. And again, I'm going to pipe this into the tidy function so that I get my results as a table. All right. So again, if you want to group the categorical variables, all right, as your explanatory variables, again, we're setting it up as the factor and continent, all right, factor of continents. Now my output looks like this. Again, I have a table of data where I have term as my first variable, estimate as my second, and then again, I have standard error, statistic, and p-value, which all have to do with uncertainty. And so the first value, that first line and the first estimate, the default is the first factor in alphabetical order. In this case, that first factor is Africa. Africa is the first continent in alphabetical order. So R is going to interpret the average life expectancy in the year 2007 for the continent Africa as being 54.8, and R considers this now as the baseline. Now, you can actually set up the code so that it doesn't necessarily do it in alphabetical order, but again, by default, it will do it in alphabetical order. So again, the baseline value is for the first continent in alphabetical order, which is Africa, which is 54.8. The other lines are compared against the baseline. So if you look at that next line for the Americas, the average life expectancy is 18.9 higher than the baseline, which brings us to like 73 point something, almost 74. All right, so the baseline is now gone up. All right, and then for Asia, the baseline went up by 16. For Europe, the baseline went up by 22.8. And then for Oceania, the baseline went up by 25.7, which is a big increase. And if you look at the column next to it, which is our standard error, it says that, well, yeah, there was a big increase, but there's also a bigger room for error. There's a bigger margin of error there as well, probably because the data set is a bit smaller than the other continents. All right. But again, this is how we can compare different categorical variables really, really quickly in the R programming language using tidy models. All right, that's all I wanted to show you with this particular example. So first of all, what is a categorical variable? Now, even when I talk about a categorical variable, can a categorical variable contain numerical data? And then what package and then what code did I use to model that and to find those statistics? We'll just go back and look at it, right? Make sure you take a note of that. Make sure you understand how we can set up categorical variables and use that same type of function. All right. That wraps it up for this video. As always, take care of yourselves.